The second pilot site selected for the demonstration of the IDs project is located in the Bordeaux 1 campus, located in the southwest of France. This area houses the University Institute of Technology, which is a pilot site of IDs. The institute provides teaching and office facilities for some 2,000 students and 500 staff, such as teachers, researchers, technicians, or administrative staff, in 11 buildings over a surface of around 40,000 square meters. Most of the buildings in the demonstration site were constructed in the 70s. However, many have been refurbished recently. Almost all of the buildings are used for teaching. Also, some of them also house offices, workshops, research laboratories, and cafeterias. There is also one building on site and one boiler house. The use of the site is highly variable, with many parts of the buildings occupied only occasionally and various energy uses. The French site currently represents sea level on the energy positivity scale, as previously mentioned by Tracey. Currently, there is no local renewable energy production on the area. To reach energy neutrality, that means A level, and cover the current energy demand, it would be necessary to produce 4,700 megawatt-hours of more renewable energy per annum. This means, for instance, a bio-based CHP producing all the heat and 70% of electricity and around 3,000 square meters of PV panels. Local energy storage could also be introduced to better match the timing of production and demand. Let's have a look at the incremental steps for reaching energy positivity for this pilot site. As you can see in the picture, the demonstration phase aiming at providing empirical evidence of the benefits of the tools developed in IDs in terms of energy positiveness, total cost of operation, CO2 emissions reduction, and improved services for users was done based on 3 items. The first one is the analysis of real energy consumptions measured in the pilot site. The second one was the assessment of the user interface's impact. And the last one was the EMS outcomes, providing simulated results for different energy optimization scenarios. Indeed, the EMS implemented for the IoT side has allowed the testing of different scenarios of optimization. These scenarios are all based on the introduction of local energy production, that means a CHP plant and PV system, with different sets of parameters for running them. The French pilot site is monitored by the NeighbourhooD Energy Management System, which is based on the IBM Intelligent Operations Center in France. The EMS receives data from the monitoring infrastructure deployed on site. This monitoring system collects the energy consumption for both heating and electricity at site scale. The system also collects electricity data at building level and additional features related to the occupancy of this building, as well as local solar irradiance conditions. The main heat supply for the site is a general gas boiler fed by the gas network, and the pilot site is also connected to the power grid. The EMS integrates also energy pricing information used for the optimization and simulated trading. The EMS optimizations and simulation are also connected to a weather forecast service for the area. The EMS extends the pilot with a simulated biofuel CHP plant, a simulated heat storage, a simulated PV production system, and a simulated electricity storage. The EMS can be adjusted to optimize either for minimal cost, for minimal CO2, or a mix of both. The size of the simulated energy sources are designed to match the pilot energy demand. In order to test the EMS, the process illustrated in this slide was followed. 2 local energy sources were simulated and several optimization scenarios were tested in order to identify the most promising or realistic approach to move the neighborhood towards energy positivity. For the 2 most promising scenarios, the key performance indicators developed in the IDs project to measure the energy positiveness of a neighborhood are calculated. These are compared to the current situation at the site based on the calculation of the same KPIs for the French pilot site as it was at the beginning of the project. Some words now about the user interfaces developed within IDs and deployed in the French pilot site. So first, the 3D virtual world developed within the project is used to demonstrate the energy positive neighborhood concept to remote visitors. The idea is to provide remote visitors with a virtual venue to learn about the IDs project into an immersive, rich, collaborative environment without the need to actually visit the project pilot site. The virtual environment incorporates simulated energy production and storage elements into the neighborhood representations that do not exist in the real site, and shows how these are integrated into the intelligent energy management that is developed as part of the project. The environment attempts to be realistic in order to involve the students as much as possible and inform them about the states related to energy consumption at site level. The shared 3D virtual space replicates a portion of the IoT pilot site focused on the building of the civil engineering department. The developed system is connected to the EMS, and the virtual site enables the visualization of the real-time energy consumptions that are available through the actual measurements equipment installed on site. It also presents some simulated production systems embedded inside and illustrates positive neighborhood functioning. For example, energy production systems such as PV panels, wind turbines, and energy storage are simulated, and their simulation data are provided by the EMS. Therefore, this virtual world interface provides a strong method of engaging student participation in the energy efficiency of the campus, and so in helping to run and maintain the EPN on that site. It also enables to host external visitors from all around the world and help in the dissemination of the ideas and targets of the IDs project. The service provider interfaces are those hosted by the IBM IOC embedded web portal, and that is used by the service provider staff defined as part of the business model definition. The purpose of this interface is to provide both executive and operational views at the demo site level or at a more detailed level. The main dashboard of the tool displays current weather data, current level and trend of electricity demand, the same for heating demand, as well as other simulated data coming from the EMS. The values which are shown in the interface are the ones produced by the latest simulation workflow and typically cover a 1 hour period of time. The energy production at the site level includes past and predictive data as shown on the screen in the lowest part of the slide. The awareness interface, which has been developed, offers an overview of the neighborhood and then zooms slowly to arrive at a more detailed level. They show nearly real-time consumption as well as historical data. In order to attract the attention of the occupants, tailored notifications are also proposed, as well as tips and a quiz to promote sustainable behaviors. User interfaces are running and displayed through 5 large screens, which have been installed at strategic locations at the IoT site. The interface rotates automatically through the different pages according to a predefined scenario. When tailored notifications become available, the slideshow is paused and the notification is displayed full screen. The awareness interface application at the French site aims to achieve 2 specific objectives. First, to educate students, teachers, and the other building occupants about energy efficiency of their surrounding environment, and to provide and inform them about the impact they have on their university. And now let me provide you some results about the impact of these tools. So first of all, we've got results that underpin our proposed business model for an EPN. The evolution of energy consumptions in the IoT site shows a slow decrease along the years when comparing the energy measurements to those of the baseline period. Moreover, the tested optimization scenarios allowed the identification of sets of conditions for which the KPIs that were calculated demonstrate the positivity of the site as well as reduction in CO2 emissions. A reduction of 40 to about 60% is reached for the most promising scenarios. Moreover, in terms of energy costs, the reductions calculated for the most promising scenario are close to 50%, which is above the initial objective stated for the IDs project. The qualitative assessment of the user interfaces at the pilot site shows that the interfaces were well received by users. The occupants of the site are now more aware of their energy consumption and know how to reduce it. Some of the students have been involved in the 3D virtual world development, and this approach is entirely in line with French guidelines for the concrete actions associated to the project's management of sustainable campuses. Moreover, the energy consumption information made available to staff through the different interfaces developed and implemented as part of the IDEAS project has underpinned new initiatives in energy management at the IoT site. New discussions are launched now at the IoT to investigate the introduction of PV systems in order to cover the basis electricity consumptions which have been detected during the period of inoccupation of the site. So the incremental path for reaching energy positivity would look like this, as previously said by Christian. The urban planning tool is used for decision support at early phase of a project. Even if the user interfaces have a minor impact, they are necessary in order to generate a collective awareness. The EPNs optimizations and predictions are expected to have a significant impact, greater than 20% on the energy savings, CO2 reductions, and profits. Furthermore, the proposed introduction of renewables and local energy sources, which seems to be in line with IoT evolutions, raises the area positivity with more than 3 levels for the IoT case. So using the tools implemented during the IDEAS project, the IoT site has theoretically moved closer to the energy positivity.
Hello. Now we would just like to say if you are a municipality, a utility company, an ESCO, a district heating supplier, or a facilities manager, or you simply own and run a group of buildings, our multidisciplinary expert team can tailor the ideas, technologies for the development of your future energy positive neighbourhoods. Yeah, and help you develop strategic roadmaps towards energy positive neighbourhoods. Okay. Pascale, can we move to the next slide? And at this point, we would like to say thank you very much. And if you want to contact us, there is an email address here and also our website address where you will find all of the reports and deliverables from the project. Thank you, and I look forward to your questions.